Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from 1 to infinity, natural log of x over x cubed dx. This is an improper integral. We see that by the infinite limit of integration. So by definition, this is equal to the limit as b goes to infinity. The integral from 1 to b, natural log of x divided by x cubed dx. We're going to have to find an antiderivative of natural log of x over x cubed if we want to get this done. So let's take that over here. This is the same as the integral natural log of x times 1 over x cubed dx. So we can use integration by parts here. We can let u be natural log of x. du is 1 over x dx. dv would be 1 over x cubed dx, so that v is going to be the integral of x to the negative 3. 1 over x cubed is the same as x to the negative 3. And then when we integrate that, we get x to the negative 2 divided by negative 2. Notice here that 1 over x is the same as x to the negative 1. So integration by parts tells us that our original integral will be equal to u times v. So negative 1 over 2 x squared natural log of x minus the integral of v, which is negative 1/2 x to the negative 2 du, which is x to the negative 1 dx. So we're getting there. Negative natural log of x divided by 2x squared. The negative 1/2, I suppose, could come outside. And we really have the integral x to the negative 3. You add the exponents when you're multiplying those two powers of x together, and you get negative 3. Integrating that, we have 1/2 x to the negative 2 divided by negative 2. Negative natural log of x over 2x squared minus 1 over 4x squared plus c. So there's our antiderivative. We can use that in our limit here. So this becomes the limit as b goes to infinity of that antiderivative, which is negative natural log of x over 2x squared minus 1 over 4x squared, evaluated from 1 to b. Now that we're with a definite integral, we don't need that plus c that we had over there in red. We evaluate by first substituting in the upper limit of integration, so negative natural log of b divided by 2b squared minus 1 over 4b squared. Then we subtract and we put in the lower limit of integration, which is 1, so negative natural log of 1 over 2 times 1 squared minus 1 over 4 times 1 squared. And then we're going to have to do that limit. The first thing that we should notice is that this second term consists of only constants. And so when you take the limit of that, you're just going to end up with that constant. So let's evaluate that really quickly. The natural log of 1 is 0. 0 divided by 2 is just 0. So there's 0 minus 1 over 4. Okay, so there's what we have for that term. Now in the first term, we might have to do a little more work to do this limit. The limit, since b is going to infinity, natural log of b goes to infinity, so negative natural log of b goes to negative infinity. B goes to infinity, so b squared goes to infinity, 2b squared goes to infinity. This becomes then an indeterminate form, negative infinity over infinity. For the second term of this part, b is going to infinity, b squared goes to infinity, 4 times b squared goes to infinity. 1 over 4b squared goes to 0. The denominator is getting larger and larger and larger, so the numerator divided by the denominator gets smaller and smaller and smaller. So the only thing left to do is to really evaluate this first indeterminate form part. So that's this part. We can do that using L'Hopital's rule. So by L'Hopital's rule, we get that that is equal to the limit as b goes to infinity. The derivative of the numerator, the derivative of negative natural log of b is equal to negative 1 over b, divided by the derivative of the denominator, which is 4b. 4b is the same as 4b over 1. If you multiply by the reciprocal, negative 1 over b times 1 over 4b, you'll get negative 1 over 4b squared. Negative 1 over 4b squared. Now we see that as b goes to infinity, 4b squared is going to go to infinity, so this whole fraction, negative 1 over 4b squared, goes to 0. So in the end, we have 0 plus 1/4, which is 1/4. This tells us that our original integral from 1 to infinity of natural log of x divided by x cubed dx converges. Let's write the conclusion. So the integral from 1 to infinity natural log of x divided by x cubed dx converges. And is equal to 1/4.